Hello and welcome to IoT World Today. I'm Lauren Horwitz, Senior Content Director at IoT World Today. And today we're going to talk a bit about industrial edge compute. There's been a lot of talk recently about bringing certain tasks to the edge, enabling faster response times, even ensuring greater security of the data that resides there, and thereby circumventing that round trip that data has to make to the cloud when you enlist cloud computing. So today, to talk a little bit about some of the benefits and also some of the challenges of using edge with industrial, I'd like to welcome Alex West, who's a Senior Principal Analyst at Omdia. Alex, welcome.
Thank you very much, Lauren. Thanks for having me.
So I'm looking forward to this discussion, and I'm going to start with just kind of a basic question. Tell us a little bit about what edge means in the context of industrial.
Yeah, it's a good question, and it's one that there's a lot of different opinions on. So it's one that's still a topic of debate where we think that companies are looking at some companies investing in large on-premise data centers, but going all the way down further to the field. And so as part of some of the research that we did, we looked when looking at the industrial edge compute as subserver level. So really what we've seen is that beyond just the local data centers, there's that need for really high levels or low levels of latency where you're talking to the single digit millisecond level. So what we call the far edge. And here we're seeing equipment such as industrial PCs, but even traditional automation equipment like PLCs and all the way down to sensors being incorporating a level of processing. And so when we've talked about industrial edge, we're not just talking about has it got a microprocessor on board or a microcomputer, but it goes beyond that to what are the capabilities that enable it to communicate with the cloud even. So can it be orchestrated? Does it run an OS that enables containerization? So some of the technology we can talk about today. But so really when we talk about the industrial edge, we're talking really around the far edge where latency is such a critical issue.
And let's also talk about why it's become so important now. I sort of alluded to it in my intro, but tell viewers a little bit about why it's come to the forefront.
Yeah, so why now is a good question. If we look at what's happening really in terms of development of technology and also where we've come from, a lot of the initial developments around industrial IoT, the platforms were almost exclusively cloud-based, just because that's where the technologies were that could host this sort of processing. And there's still some concerns around the cloud, as you alluded to in your introduction. You know, there are companies that are still worried that concern, I would say, is diminishing to a degree, but still exists, and also limitations in some applications where maybe the cloud just doesn't necessarily suit all applications. But there's also developments on a technology perspective. On a connectivity side, and I show here an example of installed base of machinery. There's lots of machinery out there. You know, many machines now, most machines are sold with a level of connectivity where they're IP addressable. They're, if you like, industrial IoT machines. But when you think about the broader installed base, these machines are 10, 15 years, some multiple decades in the field and weren't designed for connectivity. But we're reaching that critical mass where connectivity is now at a point where you can get data from your devices. At the same time, something like processing power has traditionally been very expensive. When we think of developments in Moore's law, I like to give an analogy to the PlayStation. You know, if you were playing on your first PlayStation, you had processing power of, you know, maybe 100 megaflops, and a gigaflop of processing power might cost you all the way up to sort of $42,000. If you've been lucky enough to get to a PlayStation 5, you're now talking 10 teraflops of processing power and single-digit cents in terms of the cost of processing. So that processing power has really come down, along with, you know, other developments in the market have made it cost effective. So that's really one of the open doors. I think other approaches are also being considered around. We're seeing greater convergence around IT and OT. So approaches for IT are slowly being introduced into the manufacturing space, and so also that's opening up opportunities for things like open standards, which are really going to help with that development of edge-based solutions, and also by extension making some of this equipment become more application agnostic. So really where you're going to have processing at the edge is really opening up a door where devices are going to be essentially a piece of compute, and the software is going to define some of the applications. So it's opening up some interesting ideas for the evolution of automation.
So as we look to the future and we think about smart factories, more automation, tell us some of the interesting use cases that industrial edge is enabling.
Sure. So I think when we talk about industrial edge, it's important to consider it alongside the cloud. So for some companies, it's do we go cloud or do we go edge? And in terms of that, I think it's very much application based. We can't say everything cloud or everything edge, but certainly the industrial edge brings in a number of benefits that can't be achieved by the cloud. And one of these, probably most commonly mentioned, is that of latency. So if you think of an example of a bottling line, I think the latest Coca-Cola can machine is processing something like 2,000 cans a minute. Now, if you're trying to do any sort of monitoring on that, where you need real-time reaction, the cloud is certainly just not something you can do. There, you're going to need edge computing. In addition, there can be challenges around the cost of sending data. We heard an illustration, a company that decided to go all in on cloud and were faced after the first month with a multi-million-dollar phone bill. So, edge is going to be key for processing that local data and pre-processing data as well. At the same time, there are limitations. Edge isn't going to do everything. You're going to, in terms of more computationally power intensive algorithms, that's going to need to be done on the cloud. And so we really talk about training some applications on the cloud, but then deploying them and inferring at the edge. So a good example of this in terms of the different applications might be something like predictive maintenance, where if you're monitoring the health of an asset and predicting a failure potentially a week or two in advance, that's not something where you need low latency. So potentially that is an application where you could run it on the cloud.
Mm.
Conversely, if you're talking about something like managing the quality of something where you're running through a multi-stage process, you want to make sure that you're not getting too far down the line in the process before identifying imperfections, before waste that might be introduced through adding components. For example, if you're making a phone, you want to identify the issues in quality very quickly. And so in those cases, you may well want to run your models on the edge to be able to pick up any issues very quickly.
Okay, that makes sense. So we started to talk a little bit about some of the challenges of working at the edge, but can you outline some of them for viewers?
Yeah, sure. So we've really looked at kind of what's that best case and worst case for the future opportunity. I would say there are kind of barriers that the market for industrial edge still needs to see. One is just in terms of that, how is this market going to evolve in terms of end users' preference in terms of using cloud, using edge, how they're going to work on these, what we believe optimal in many cases solutions where it's a hybrid approach. But other technology factors are going to come into play. TSN is one of them. So that's time sensitive networking, which is a connectivity solution that's really going to enable a lot of that low latency communication. Now, there's continued developments alongside 5G as well, around getting standards in place, getting this out to market, getting to a point of critical mass where there's enough devices out on the field to support this connectivity alongside the edge. Another element is always education. We're talking about really technology that's on the cutting edge. And when we think of the manufacturing space where transitions in technology can often take a lot of time, education is really going to be crucial, especially when talking about edge and what the benefits that can be really utilized from the edge. So when we think of the introduction of artificial intelligence and new programming languages and new approaches to automation, these are things where education is going to play a crucial role in helping end users understand how to apply. So I would say that's another barrier. And maybe one other good example is standardization. And this is always crucial. Again, the manufacturing space has struggled with the issue of a lot of proprietary solutions, a lot of vendor lock-in, whereas conversely, we see the opportunity is really going to be accelerated through release of open standards. So breaking down those sort of traditional proprietary solutions. So as we see that take place and the establishment of certain open standards, that's really going to be another barrier or challenge that needs to be overcome before we really see an acceleration in edge.
And it's interesting that you say that, because I had a conversation earlier today with some folks developing edge for home automation uses. And there was a lot of discussion about this need for APIs to enable devices to talk to one another, even to offload tasks to one another, if they're guided by different protocols. So speaking that common language, having those APIs to enable data silos to kind of come together and tasks to happen in unison. Would you? Yes, you're nodding your head.
Yeah, I would absolutely agree. And again, that ties into that idea of IT and OT convergence. You're talking about data running more seamlessly. And I mentioned a technology like time-sensitive networking. That's going to be a technology amongst some others that is really going to enable that interoperability of devices, breaking down the barrier of, a plethora of proprietary solutions that we have in the industrial space at the moment. So
Yes.
certainly we see that as where the market is heading.
So, and that sort of sets the stage for the last question I wanted to ask you, which is, IoT in general, and even in industrial IoT these are fragmented landscapes, right? There are a lot of players, a lot of different technologies that are coming together. Could you talk a little bit about the landscape and what people researching and buying might expect as they go out there?
Yeah, sure. And that's a market where if you look at the industrial space and the space for industrial IoT and the analytics, there's a host of companies battling over this middle ground of analytics. So you have the equipment vendors who have traditionally sold automation and hardware. They're looking to move up and provide their customers with additional services. How do they use the data that's generated from their equipment to enable the manufacturers, their customers, to make better decisions, to optimize the processes, to identify faults, for example, early on. And so there's a business model there. And so everything from the bottom level, where you have the sensor vendors who are, really at the point of collection of data. These companies are introducing gateways, partnering with cloud vendors, and offering applications that support analytics of data. And we see this across the entire range, from gateway vendors